Hello everybody, I am Gautam Dashottar representing VIT Vellore India. I am here to participate in the Simulink Student Challenge and to present our flagship project Colossus.
Code and Simulink model starts with the code RChem Model 1. The script starts by extracting components of the state vector x, the control vector u for readability. It then defines various constants related to the aircraft, such as mass, dimensions, positions, aerodynamic coefficients, etc. Control limits. These are defined limits and saturation conditions for control inputs U1 to U5. Intermediate variable calculation. It computes airspeed, angle of attack, side slip angle, and dynamic pressure based on the state variables. Aerodynamic force and moment calculation. Using aerodynamic equation, it calculates the lift force, drag force, side force, and dimensional forces in stability and body axis. Aerodynamic moment and coefficient calculation calculates the aerodynamic moments, coefficients, and the transformations about the aerodynamic center. Engine force and moment calculation considers the engine thrust and its movement about the aircraft's center of gravity. Gravity effects calculation computes the gravitational forces acting on the aircraft. State derivative calculation computes the derivatives of the state variables x dot using the aircraft dynamics, inertia, and the forces and the moments acting on it. It calculates the rate of change of velocities x1 to 3 dot, angular velocities x4 to 6 dot, and Euler angles x7 to 9 dot. Additionally, it calculates the derivatives for navigation equations x10 to 12 dot. The code constructs the derivative of the state variables x dot containing the rate of change of state variables. This is our Simulink model. The model starts with a joystick block set which takes in 5 user inputs. These 5 inputs are sent to the nonlinear 6 degree of freedom RChem model block set. These 5 inputs are sent to the code shown earlier using the interpreted MATLAB function, and we get 12 outputs. These 12 outputs are sent to the scope block set. Now, the next step is calculating the geodetic position. The geodetic position helps in determining the aircraft's coordinates in a 3D space. This is done using the WGS64 block set shown here. Now, Now, the next step is to connect the Simulink model to the flight gear. This is done using the pre-configured flight gear block set, which takes in 6 inputs, namely the three of which are the geodetic position, along with longitude, latitude, and the altitude, and the rest three are the Euler angles, namely phi, theta, and psi.